Good morning, class. Sorry I can't be there today. The Hanson household is under the weather, so hopefully we'll rest up and I'll be able to see you tomorrow. In the meantime, I just wanted to thank you for your response to yesterday's video. I believe that I got my message across, and my only concern is that it's not going to last more than just a day. So please use yesterday as momentum moving forward. Continue to do the right thing every day. I know it's not easy to do, but that's the expectation. And if we truly want, I think we all deep down inside want a culture of positivity and respect and love and care. So we need to be actively contributing to that if that's what we really want. And if not, then I'm not quite sure what you're doing as a human being. But you're my little guy in the background there. He's having a rough morning. So anyways, let's get to it. So here are the answers, and the idea is that even though you have the answers at your disposal, you still need to know how to do the problems, because when the assessment comes on Friday, obviously you're not going to have the answer key in front of you. So the purpose of this is twofold. Number one, to give you confidence in preparation for Friday, and number two, obviously, to even though you have the answers, know how to get the answers. So sometimes if you take the solution and work backwards, it can be a little bit more effective. And that's kind of the idea that we're working with today. So let's get started, shall we? For the multiple choice, remember it is always a good idea to eliminate answers that you know are wrong. And a lot of times the strategy for multiple choice is a little bit different than it is for short answers. So just keep that in mind. Number one, which ordered pair is not a point on the graph? Is not a point on the graph of y equals negative 5x plus 2. Okay, so first of all, just a couple of background points. Number one, they're looking for the ordered pair that is not a point. So, in other words, which is false. Here is an equation, y equals negative 5x plus 2. This should look very, very familiar. It is a linear equation. In other words, if I graphed this, it would be a line. All of these ordered pairs are potentially on this line, meaning this is the x value and this is the y value that makes this statement true. And we're trying to figure out which one does not make it true. My recommendation as far as a strategy for this is to use all of the x values, plug in the x values, and see if you get the matching y value when you calculate it. So, letter A, the x value is negative 1, which means I'm going to substitute negative 1 in for the x. Negative 5 times negative 1 is positive 5, plus 2 is 7, not 6. So right away, it's looking like letter A is going to be my answer. Let's continue just for practice sake. B, if I put 0 in for x, negative 5 times 0 is 0, plus 2 is 2. Well, that matches. Negative 2 for letter C goes in for x. Negative 5 times negative 2 is positive 10, plus 2 is 12. That matches. For choice D, 2 goes in for x. Negative 5 times 2 is negative 10, plus 2 is negative 8. That matches. So I was right initially. The ordered pair that is not a point on the graph is choice A, because I don't get a matching y value when I substitute in the x. So there is a problem on the test like that Friday. Don't mess that up. Number two, what is f of negative 3 if f of x equals 1/3 x? Okay, so this is function notation. It technically is linear as well, because f of x is really the same thing as the y. It's just taking the place of the y. And it's just a different notation. So f of negative 3 means wherever I see an x, I'm going to substitute a negative 3. So I'm going to, if you remember, calculate this by doing f of negative 3 equals 1/3 times negative 3. So again, wherever there is an x, I'm going to substitute in a negative 3. That's how I calculate the output of a function. So 1/3 times 3 is 1, and I have this negative sign, so it's going to be negative 1, which is choice H. That's why I have choice H over here. Number 3. The graph at the right shows Lana's total distance in miles for each day she is training for a marathon. What is her distance on day 10? So let's look at the graph. A couple of different things that we can determine from the graph. First of all, it would appear that this is linear. It's a constant rate of change. In other words, if I attempted to draw a line, it looks like if I start from 0 and try to go through these points, that I'm going to have a linear function. Okay, so that means a couple of things to me. Number one, if the function is linear, that means I have a constant rate of change. So if I look at the x and y values here, 1, 3, 2, 6, 3, 9, 4, 12, 5, 15, it looks like a constant rate of change of 3. In other words, the x times 3 equals the y. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, etc. Following that pattern then, day 10 would be somewhere over here on the x axis, which means I should be able to multiply 10 by 3 to get the y value. 10 times 3 is 30, which would be choice C. Number 4, which table represents a linear function? Remember, we just talked about it. To have a linear function, I need to have a constant rate of change. So the first thing that I would do is check the y values to make sure that they're increasing or decreasing by the same amount. Plus 1, plus 3. Plus 1, plus 1, plus 1. Looks good, but you also recall that I recommended also looking at the x values to make sure they are also increasing or decreasing by the same amount, just to verify. So plus 2, plus 2, plus 2. So right now G's looking good because the y's are increasing by the same amount and the x's are increasing by the same amount, which would indicate a constant rate of change. Let's check H. Plus 1, plus 1, plus 1. Okay, that looks good so far. Let's check the x's just to verify. Plus 2, plus 3. Uh-oh, plus 6. Okay, so no. So this is a great example of why you should check both. The y's are good. The x's are not. So even if the y's are increasing or decreasing by the same amount, also check the x's to make sure, because this is an example where that is not the case. This this rate of change is not constant. Letter I, just to be safe, minus 2, minus 3, no, minus 4. So that rate of change is not constant either. I'm going with choice G. Number 5. Kayla's monthly cost of sending text messages can be represented by the function y equals 0.07x, where y represents the total cost and x represents the number of text messages. The table shows Aubrey's monthly cost of sending text messages. Which statement is not true? Okay, so a couple things going on. First of all, I'm talking about two different people. I've got Kayla represented by this equation, and then I have Aubrey represented by the table. So I'm comparing these two people. And then I also have, just kind of like number 1, which statement is not true. So I want the false statement, in other words, if you want to think of it that way. If I want the statement that is not true, that means I want the statement that is false. So multiple choice, we kind of have to work through each one to decide, or at least eliminate answers that I know are incorrect, and I can kind of go from there. So first of all, understand that we got two different things going on. This is obviously a linear function. This also should be a linear function. Let's take a look at the rate of change. The cost is increasing by 1. By the way, the cost is the y value and the text messages of the x value, just in case you don't recall that. Cost is increasing by 1, and then the messages are increasing by 10. So remember that rate of change is the y divided by the x. So the rate of change here is 1 over 10. Okay. 40 minus 30, 19 minus 18, just to verify, 1 over 10. Which, if this is a decimal, I should also represent this as a decimal. So this is 1/10, which is 0.1. In other words, if you think of it in terms of spending, it appears that Kayla is basically spending 7 cents per text message, and Aubrey is spending basically 10 cents per text message. Now there's a little bit more to this, but we'll get to that later. So essentially it's 7 cents per text, 10 cents per text right now. So letter A. Kayla pays $10.50 for sending 150 text messages. So we're dealing with Kayla. We're dealing with this equation right here. $10.50 for sending 150 text messages. What I need to do is substitute 150 in for the X value. Okay, so I'm doing 150 times 0.07. If you do that, you get 10.5, which is the equivalent of $10.50, which means A is true. Kayla does pay $10.50 for sending 150 text messages. So if I'm looking for the answer that's not true, excuse me, I'm not going to pick the one that is true. Letter B. Aubrey pays $30 for sending 150 text messages. So again, same deal. Now I'm talking about Aubrey though, so I'm going over here in the in her table to see what's going to happen. A couple of different ways to look at this. Okay, first of all, if 150 text messages is not in this table, I could very easily create that though. So let's think of it this way. You could do one of two ways. You could increase this all the way to 150. That's going to take all day, and calculate the cost and see what the cost would actually be. Here's a little shortcut for that. So I have this 50 right here, right? 50. So I could increase my table to 100 and then to 150. Now, here's the issue. How am I getting from 50 to 100? I'm multiplying by 2, which means I need to multiply 20 by 2 to get to the y value that corresponds to 100, which means for Aubrey it costs $40 for 100 text messages. 50 times 2 is 100, 20 times 2 is 40. Likewise, I could go from 50 to 150 by multiplying by 3, which would indicate that I'm sorry, that would indicate that 20 times 3 is 60. Okay, so just so that we're not, because it's going to take a long way to get to where you need to go. It's going to be, if it's $20 for 50 text messages, it's going to be $40 for 100 text messages, and it's going to be $60 then for 150 text messages. Aubrey pays $30 for sending 150 text messages. Is that true? I don't think so. So I believe we're choosing B for that. Well, let's just be sure. Okay, I know it says D, and I'm going to show you why, because oftentimes remember, the book makes mistakes. So I'm going to go ahead and highlight the fact that right now this is not true. It does not cost $30 to send 150 text messages right now. And we're going to come back and prove to you why that's true. Let's move on, okay? Letter C. Aubrey pays more per text than Kayla. Okay, well, technically, remember we just talked about this. Kayla is paying about 7 cents per text. Aubrey is paying 10 cents per text. So Aubrey pays more per text? Yes, she does. 10 cents is greater than 7 cents. So that means that statement is true, which means it's not true. Choice D. Aubrey's initial cost is greater than Kayla's initial cost. Aubrey's initial cost is greater than Kayla's initial cost. So here's where it gets a little bit tricky. Okay, so based on my table, right? Based on my table, I don't know what the initial cost is. I could very easily find that. Let me erase some of the stuff that I have here, and we'll be able to show you how to do that. If you recall, sometimes you had to finish the table all the way down to 0 to see what the initial cost is, and that is exactly what you're going to do here. So the lowest value right now on my table is 30, which means I'm going to go to 20, and I'm going to go to 10, and I'm going to go to 0. These are increasing by 1, which means if I'm going to subtract, I'm going to decrease by 1. So 20 text messages would correspond to $17. 10 text messages would correspond to $16, and 0 text messages would correspond to $15. So it sounds like there's a $15 fee for Aubrey plus 10 cents per text message. Okay, so she's paying more no matter what. So that brings me to this point. 0 text messages is going to cost $15. That means her initial cost is $15. Aubrey's initial cost is $15. Kayla does not have a visible intercept with her thing. It doesn't say 0.07x plus blah blah blah. There's nothing here, which means technically it's plus 0, which means there is no initial cost for Kayla's monthly cost for sending text messages. So Kayla is paying $0 initially. Aubrey is paying $15 initially. So Aubrey's initial cost is greater? Yes, it is, which means this is true. So again, I think the book made a mistake here, and I believe the correct answer for number 5 is choice B, which is Aubrey pays $30 for sending 150 text messages. Let's move on. Number 6. Which of the following represents a non-linear function? Non-linear. Okay, so again, multiple choice. What's the difference between linear and nonlinear? Linear means it's going to make a line, right? So y equals mx plus b form. Does that look like y equals mx plus b? No, it doesn't. The dead giveaway is the exponent of 2. That means it's a quadratic. We learned that in lesson 8. Anytime you have an exponent of 2, this is a quadratic equation. Quadratics are curves. They look like that, remember? That is not linear. So to save us some time, I'm choosing F because F is nonlinear. Y equals x, that's a line. Y equals negative 9x, that's a line. Y equals 8x plus 10, that's a line. So the only nonlinear function on here is choice F. Number 7. Roberto has a certain number of songs on his MP3 player. Each week he plans to add 4 more songs. After 5 weeks, he had 40 songs on his MP3 player. Which statement is true? Okay, so now, of course, after doing 2 problems in which I was looking for not the answer, now I'm looking for the true statement, okay? So again, multiple choice gives me some options. There's certain ways to do it. So let's backtrack and see if we can decipher a function to represent this situation. Roberto has a certain number of songs on his MP3 player. I don't know how many. Each week he plans to add 4 more songs. So each week, 4 more songs. After 5 weeks, he had 40 songs on his MP3 player. Which statement is true? Okay, this is an example of a situation in which you might want to create a table. Okay? He's adding 4 songs each week. In other words, 4 songs per week. In other words, 4 songs times the number of weeks. So here's what my table is going to look like. I'm going to go weeks, and I'm going to go songs. Apologize for the handwriting. Weeks is going to represent my x value. Songs is going to represent my y value. And I'm going to go 5. After 5 weeks, he had 40 songs, so I know what that is, 40. And then I can go 4, 3, 2, 1, 0. Because I might need to know the initial value. Okay, you get the idea. All right, if he is increasing here, I know that bugs me too, and we'll fix it. Whoops, not what I wanted to do. I guess I can't fix it, can I? Sure I can, sort of. I guess we'll just leave it alone. All right, there we go. Good enough. So if each week he is adding 4 songs, that means this should be going plus 4, plus 4, plus 4, plus 4, plus 4. So if I'm going to work backwards, that means I'm going to subtract 4. Yes? Okay. So 40 minus 4 is 36. 36 minus 4 is 32. 32 minus 4 is 28. 28 minus 4 is 24. And 24 minus 4 is 20. So there are my corresponding, my corresponding y values. It's kind of difficult to see, I apologize. Let me move it to where you can see it. Okay, so week 0, he had 20 songs, which means he started with 20. The initial number of songs on Roberto's MP3 player is 20. So right now I think it's choice D. Let's go back. Roberto adds 5 songs on his MP3 player per week. No, he adds 4 per week, so that's completely false. Roberto adds 10 songs per week. No, he adds 4, so completely false. C, the initial number of songs on Roberto's MP3 player is 10. No, week 0 it's 20. So again, based on process of elimination, I know it's D, but I also know it's D because it says the initial number of songs is 20, and there's my 20 right there. Okay, so 7 is D. Number 8, state the domain and the range for the following relation. Remember that the domain is the set of x values, the range is the set of y values. So the domain should be 4, 3, 0, and 1, preferably in numerical order, 0, 1, 3, 4. And then the range then is going to be the y values, -1 to -3 and 4. And again, preferably in numerical order from least to greatest is what I meant to say. So -3, -1, 2, 4. Easy peasy. Don't miss those points. By the way, we're on to the short answer. I'm sure you realize that by now. So again, set notation. You can just write the letter D for domain. That would be fine. You can just write the letter R for range. That would be fine. You do need to make the squigglies though. Those are called braces. The numbers should be in braces. That's called set notation. It is specific. Complete the function table number 9 for f of x equals 3x plus 2. So again, f of x is basically representing the y value in the table. I'm going to take all of these values and substitute them in. You should be really good at this by now. -2 times 3 is -6 plus 2 is -4. -1 times 3 is -3 plus 2 is -1. 0 times 3 is 0 plus 2 is 2, and 1 times 3 is 3 plus 2 is 5. No problems there. Consider the following situation. Grocery store number 10 sells, 10 and 11, I'm sorry. Grocery store sells bacon for $5.30 per pound. So each pound is $5.30. 1 pound is $5.30, 2 pounds is $10.60, etc. Write a function to represent the situation. Okay, bacon, $5.30 a pound. In other words, it does not tell you, I guess they're using C for cost and P for pound. You could also use y and x, obviously, we talked about that. So this could also be y equals 5.3 times x. That would be perfectly acceptable. The letters are not important unless they tell you what letters to use. They don't tell you what letters to use, so use whatever letters you want. But these two equations are equivalent, so either of those is fine. Is the function continuous or discrete? Okay, continuous means you can break up the x and y values into fractions or decimals. Okay, so it's $5.30 per pound. Are there fractions of pounds? Yes, there are. Are there fractions of dollars? Yes, there are. They're called cents. So I'm not going to go to the store and buy exactly a pound. If I do, that means that the deli guy is an ace and can measure exactly 1 pound. But generally speaking, it's usually a little over or a little under, regardless of the number of pounds. So it's going to be a decimal or a fraction value of pounds, which means that it's not going to be exactly $5.30. So it's continuous because it says you can have a fraction of a pound when you weigh bacon. Very simply put. Continuous means you can break those up into fraction or decimal values. 12. Graph this thing. This is a quadratic. We just did this the last 2 days. How do I know it's quadratic? Because of the exponent of 2 right there. So the recommendation was create a table of values. This is a naked quadratic equation. There is no word problem associated with it. So I would use -2, -1, 0, 1, and 2. A couple of things just to realize. Negative sign, which means it should open downward, upside down. +4, that's the intercept, which means it should intersect at 4. So knowing that information, I'm going to go ahead and create my table of values. -2, -1, 0, 1, 2. And those are my x's. My corresponding y's then are going to be what happens if I solve this. So again, I recommend in most cases doing the calculations, especially if it's something this extensive. So what's going to happen is, sorry, I just wanted to make sure I have my x up here. So then I'm going to have my y values over here. Y. Alright, so negative 2 is going to get subbed into this equation. Negative 2 times negative 2 squared plus 4 equals, okay, I'm going to write my squareds, so just hang on a second and come back to that. Alright, so we're good to go here. Negative 2 times negative 2 squared plus 4. Alright, don't forget order of operations. Exponents, then multiply, then add. So negative 2 squared is 4, times negative 2 is negative 8, plus 4 is negative 4. Negative 1 squared is 1, times negative 2 is negative 2, plus 4 is 2. 0 squared is 0, times negative 2 is 0, plus 4 is 4. You remember that there should be a pattern here. So this is going to be 2, and this is going to be negative 4. You want me to check it? Okay, fine. 1 squared is 1, times negative 2 is negative 2, plus 4 is 2. 2 squared is 4, times negative 2 is negative 8, plus 4 is negative 4. Okay, so I have my values that I'm going to plot, right? You can do these in any particular order. Negative 2, negative 4, that means negative 2, negative 4 is right there. Negative 1 and positive 2. So negative 1, 2 is right there. 0, 4. 0, 4 is right there. 1, 2. 1, 2 is right there. And 2, negative 4. 2, negative 4 is right there. Draw your curve. Boom. Done. Graphed it. 13. The value, excuse me, of a football card has increased steadily over time. This is a qualitative graph, right? Sketch a qualitative graph of the situation. I know that there are at least 2 of these on the assessment. So remember, 99% of the time, the X label is going to be time. I believe you just have a blank axis on there. So you're going to be responsible for 2 things, labeling the axes and then drawing the graph. So here's the thing. First of all, let's look at the things that are being talked about in this particular problem. It's a qualitative graph, so there are no numbers involved, but we're talking about value and we're talking about time. So you'll notice there's value, there's time. How do I know the difference? Well, independent versus dependent variable. Time is going by. As time goes by, the value is increasing steadily. So the value depends on the time. So the value is the dependent variable, which makes it the y, and time is the independent variable, which makes it the x. So time goes there, value goes there. Increases steadily. That sounds like a constant rate of change to me, which would indicate that it should be a linear graph. Now, the question is, why does it start right here and not at 0? Well, I guess you're assuming that the football card was initially worth something. It was not 0. Okay, so if it's initially worth something, then you're going to start your graph above 0 somewhere. And increasing steadily means that it's going to be linear, increasing steadily. Now, it's not going to look like that. That would be increasing dramatically. And it wouldn't be straight across. That would mean it's not increasing at all. So increasing steadily, just draw a line, steadily increasing, and we'll give you the benefit of the doubt. Okay? So there you have it, review 2B. Hopefully you were able to do a lot of this independently. And again, a lot of these problems are going to look very much like the ones that are on the assessment. Your responsibility now is to make sure that you have mastered 20 IXL skills by the end of the day. If you have some catching up to do, then you don't have time to waste. Please get as many mastered as you can. Thank you for your attention today. Hope the video was helpful, and I plan on seeing you tomorrow. Have a great day.